So today we want to see the differences between BJT and MOSFET. In BJT, it consists of three terminals that are base, emitter and collector, and MOSFET is having three terminals that are source, gate and drain. That's why we are seeing here three configurations: collector base, CB, CE.
मैम स्लाइड नहीं दिख रही.
नहीं दिख रहा है?
स्लाइड
शेयर तो स्क्रीन किया हुआ है बट मैंने. So you can see here BJT is having three terminals that are base, emitter and collector. In MOSFET is having three terminal: gate, drain and source. That's why there are three configurations: CS, CG and CD. C for a common. As compared to the MOSFET, in BJT there is a less input resistance. But if you compare MOSFET with BJT, then we can see here there is a very high input resistance. And if you see about the thermal noise is more in BJT, but as compared to BJT, thermal noise is very less in a MOSFET. Then here input output relation is linear, but in MOSFET this input output relation is non-linear, because yesterday we have seen operation of a N enhancement MOSFET, N channel enhancement MOSFET. उसमें हमने देखा था when we are giving VGS, firstly what will happen? We will get output current which will increase linearly. After that we will get current increasing for some time, and we are calling this region as a linear ohmic region or a triode region. After that, if we are giving small VDS also, and if value of VDS will reaches to VGS minus VDS का जो वैल्यू है वो थ्रेशोल्ड वोल्टेज के उतना हो जाएगा, तो करंट का वैल्यू क्या हो रहा है वहाँ पे? कांस्टेंट. दैट्स व्हाई वी आर गेटिंग देयर सैचुरेशन रीजन. सो हियर इनपुट आउटपुट रिलेशन जो है it is a non-linear. And in BJT, gain bandwidth product is high, but in MOSFET, gain bandwidth product is low. These are the some differences between BJT and MOSFET. As well as if you compare MOSFET with BJT, it is having very smaller size. उसका क्या फायदा है कि on compact size वहाँ पे कम जगह है, कम IC पे यदि कम जगह है, but we can put more and more MOSFET. That's why we are using MOSFET in comparison with the BJT. Yesterday we have seen operation of a N-channel enhancement MOSFET. Today we will see about the operation of a P-channel enhancement MOSFET. MOSFET का वर्क कब स्टार्ट हो रहा था? इन enhancement mode we have seen channel is not permanently present. We have to create channel. Why we have to create channel? Because when we create channel, that time current will flow. तो करंट कैसे फ्लो होगा? जब हम वहां पे VGS देंगे. But as you guys can see here, in P channel enhancement MOSFET, we are taking heavily doped P type 2 semiconductors. That's why we have to give here VSG. And if in start we are not giving any input voltage, it means VSG या फिर VGS you are taking, it will be the 0 volt. मैं VGS की जगह यहाँ पे VSG की बात क्यों कर रही हूँ? Because here in N channel enhancement MOSFET we are taking two heavily doped N channel, but हम PE MOSFET में क्या कर रहे हैं? Heavily doped दो P channel semiconductor ले रहे हैं. That's why here we have to give VSG. Yeah, otherwise you can say we have to give here minus VGS. दोनों का मीनिंग एक ही है. If in start you are not giving any input voltage, if you are not giving any VGS, you are giving 0 volt voltage, what will happen? Current will no flow. And when you start to give VGS, and if this VSG minus VGS, or you can say it is a VSG, because we are talking here about the P channel enhancement MOSFET. N channel enhancement MOSFET में हमको क्या करना था? हम वहाँ पे दो N channel heavily doped ले रहे थे. That's why हम वहाँ पे positive VGS दे रहे थे. But यहाँ पे P channel में क्या होता है? यहाँ पे we are taking here P type of semiconductor. That's why we have to give here VSG, or you can call it is a minus VGS. Or if this value of VSG is equal to or greater than VTP, what will happen? Depletion region will increase. Then height of depletion region will decrease. That's why what we will get, depletion region will goes to the channel side and the resistance will opposite. That's why we'll get here current. ID starts to flow. सबको आवाज आ रही है अच्छी से?
मैम
प्लीज डोंट अनम्यूट. इफ यू नीड टू टॉक देन ओनली, क्योंकि मैं जब बात कर रही हूँ बीच में कोई अनम्यूट करेगा तो बाकियों को समझ में नहीं आएगा. When I am asking any question or you are facing any doubt, you are not getting my slide is not visible, that time you can unmute and you can say. Okay. Now we will see operation of PE MOSFET. But when we will give increase in a VSD. जब हम N channel MOSFET में देख रहे थे तब हम क्या कर रहे थे? Firstly we have seen, I will show the diagram here. When we are not giving any VGS, means VGS if you are giving 0 volt, तब वहां पे क्या हो रहा था? There will be no current flow. This region we are calling as a cut off region. And when it will go to the threshold voltage, यहाँ पे जो threshold voltage है, when it will reaches to the threshold voltage, what will happen? Current starts to increase linearly. That's why we are calling this a linear region. उसके बाद हमने क्या किया? We are giving VGS. But as well as we are giving small value of VDS. यहाँ पे हम क्या कर रहे थे? VDS भी apply कर रहे थे. When we are giving small value of VDS and we are giving VGS which is greater than threshold voltage, we are getting here value of ID current is increases. But when value of VDS will reaches to VGS minus VDS will be greater than threshold voltage. That time what happened here? We are getting here constant value of current. That's why we are calling this region as a pinch off region, or we can call this region as a saturation region. ये जो same concept है, this will be happen for P channel enhancement MOSFET. But difference क्या रहेगा? Instead of VGS, we have to give minus VGS. That's why we are calling it is a VSG. और पिंच ऑफ और सैचुरेशन रीजन के लिए क्या करना पड़ेगा? मुझे VDS भी अप्लाई करना पड़ेगा. बट एज हियर वी आर गिविंग सप्लाई टू द P channel enhancement MOSFET. That's why we have to give here minus VDS, or we can say VSD. Now we will move to our diagram. हाँ, तो यहाँ पे क्या किया मैंने? I am giving here VGS, it means minus VGS, as well as I am increasing value of source to drain, means minus VDS. At that time what will happen? This biasing, reverse biasing will happen heavily. That's why we will get here constant value of current. ये जो ग्राफ था ये सेम एज इट इज तुमको मिलेगा, बट दिस विल बी फॉर निगेटिव. मतलब ये जो मैंने फर्स्ट क्वाड्रेंट में आया है ये यहाँ पे मेरा थर्ड क्वाड्रेंट में आएगा. Instead, you guys can take here, instead of VDS, you can write here VSD and you will get the same diagram. एक तो तुम क्या कर सकते हो, यहाँ पे VDS को VSD लिख सकते हो. Instead, if you guys are taking VDS, you have to draw here for negative VDS and current will increase, but it will in a negative direction. This is the operation of P channel enhancement MOSFET. Now we will see about the channel length modulation. Channel length modulation means क्या है? This is the effect, early effect, which we will get in a enhancement MOSFET. How will get? When we apply VDS. जैसे कि हमने देखा है VDS if we are applying with VGS is greater than or equal to threshold voltage. And if value of VDS will goes to VGS minus VDS is exactly becoming or greater than threshold voltage, then we are getting pinch off region or we are getting here saturation region. मतलब value of current जो है वो constant मिल रहा है. And if we are increasing VDS again, and if this VDS will become greater than or equal to VD saturation, then there we will get two effects. The junction between drain and substrate becomes more reverse bias. Therefore, according to the rule of depletion region on both sides should increase. क्या होगा यदि मैं ये जो VDS अप्लाई कर रही हूँ, here we are seeing this diagram for the n channel enhancement MOSFET. That's why I am taking here VDS. और ये यदि डायग्राम तुम P चैनल इनहांसमेंट MOSFET के लिए लोगे तो क्या होगा, यहाँ पे N टाइप की जगह P टाइप सेमीकंडक्टर आएगा और यहाँ पे VDS की जगह VSD और माइनस VDS. The junction between drain and substrate becomes more reverse bias. Therefore, according to the rule of depletion region on both sides should increase. And on channel side, since pinch off means saturation region. Since pinch off cannot be shifted upward, Q, because there is a SiO2 layer, it gets shifted towards the source. ये यहाँ पे सोर्स के पास जाएगा. It will not go upward. Why? Because there is a SiO2 layer. सबको आवाज आ रही है अच्छी से?
Yes, ma'am.
Yes, ma'am.
Now we will see the diagram. You guys can see here the output characteristics of the channel length modulation. इसमें क्या हो रहा था? Here, when we are giving VDS, which will be greater than VDS saturation, there will be decrease in a length of channel. If VDS further increase, the pinch off point further shifts to the P side, decreasing the length of channel. It means if VDS is varied and it will goes above the VDS थ्रेशोल्ड, मतलब जो थ्रेशोल्ड वोल्टेज है उसकी यदि ज्यादा जा रहा है तो तब क्या होगा, द लेंथ ऑफ चैनल विल वेरी. दैट्स व्हाई वी आर कॉलिंग दिस रीजन एज अ channel length modulation. You guys can see the output characteristics graph with the channel length modulation. As we are increasing VDS beyond VDS, length will goes to decrease. Depleted area on channel will increase. Depleted जो area है on channel will get increase here, जो depletion area है, and due to which we will get here increase in electric field. That's why we will get here increasing value of that ID current. ये जो ID current है उसका value हमें क्या होगा, यहाँ पे increase हो जाएगा when we are giving VDS which will be greater than VDS saturation. It means as VDS is increased beyond VDS, ID will increase. This is the output characteristics with channel length modulation. It means slope in output characteristics in saturation region. ये जो saturation region में जो slope है, it is nothing but the indication of a channel length modulation. ये जो slope है, here it is showing there is a channel length modulation. Now we will see MOSFET as an amplifier. This is the circuit diagram for MOSFET as an amplifier. क्या कर रहे हैं हम, यहाँ पे एक MOSFET ले रहे हैं and we are taking here one input source. ये जो input source है, this is connected with ground terminal and we are taking here one load resistors. We are using here coupling capacitor CC1 at one input and at the side of output. That's why we are calling it is a CC2. This is the equivalent circuit. Now we will see how we have to solve this DC analysis. जो हम इलेक्ट्रिकल सर्किट में जो पढ़ रहे हैं अभी, KCL, KVL, these things will be useful here also, because यहाँ पे हमें क्या करना है, वोल्टेज का, करंट के वैल्यूज निकालना है. We have to derive here voltage, current, transconductance. That's why these KCL, KVL will be useful here. तो वो भी लेक्चर अटेंड करो और ये भी लेक्चर अटेंड करो. Then you will get, when we solve the DC analysis, we will get here XC equal to 1 upon 2 pi FC. And as here frequency is high, that's why frequency is less, that's why we are getting here infinite value. Now we can see how we have to solve. We have to apply KVL to input as well as output. Firstly, we will see about KVL to obtain DC load line. DC load line मतलब क्या है? ये जो यहाँ का आउटपुट है, यहाँ का ये जो लोड सर्किट के यहाँ पे जो वैल्यू रहेगी, we have to derive that value. So we are applying here KVL for this loop. स्क्रीन दिख रहा है सभी को? If you guys see, you can see here it is a loop, but here as we guys considering these as a ground terminal, तुम ये एक साथ कनेक्ट करो या फिर अलग अलग, यहाँ पे क्या है, ग्राउंड है. So when we are applying here KVL, we can see here voltage is what we are giving here, VD voltage. ये जो यहाँ पे VDD voltage है, ये यहाँ पे भी रहेगा. So we are taking here this voltage VDD. Then we are taking here directions from this side to this side. That's why if you are taking the value of voltage at RD, what we have to do? We have to take negative sign. That's why I am taking here minus ID and into RD. This is the potential drop across this resistor. Then we are seeing here, we are getting here VDS voltage. So we can write this equation as VDD minus IDRD minus VDS. We can solve this equation, then we will get the value of drain current. And you can see this is look like a slope of line, y equal to mx plus c. C is constant and m minus 1 by RD जो है, this is the slope. So we can say here this is the slope of line. Now we will see the significance of a DC load line. DC load line is used to set up maximum DC voltage and current such that AC output voltage and current cannot exceed the DC value. इसका मीनिंग क्या हो रहा है? DC लोड लाइन यूजफुल है हमें मैक्सिमम DC वोल्टेज एंड DC करंट का वैल्यू मिलने के लिए. एंड what will happen? It will not allow to exceed the DC values. That's why we need the value of this DC load line. You guys can see here, ये जो saturation region है और ये जो slope है ID का, ID equal to VDD by RD, ये जो है ये यहाँ पे दोनों एक दूसरे को कनेक्ट हो रहे हो और दिस पॉइंट इज कॉल्ड एज अ क्वेश्चन पॉइंट और यू कैन से दिस पॉइंट एज अ क्यू पॉइंट. So when DC load line is used, we will get maximum DC voltage and current, and that they will not allow to increase the DC voltage and current. The intersection of DC load line. The intersection of DC load line is a Q point. ये जो यहाँ का जो saturation region है एंड ये जो Q point है, दोनों का इंटरसेक्शन, उसको हम क्या बोल सकते हैं? क्वेश्चन पॉइंट, और यू कैन से इट इज अ Q point. Q point is selected at the center of DC load line such that positive and negative half cycle of amplified output are identical. Positive और negative जो half cycle है, that will get here identical values. You can see in this graph. When we are giving here input VGS, you guys can see this diagram. यहाँ पे when we are giving VGS, this is the time, and on y-axis we are taking here VGS. What will happen when we are giving VGS, which will be VGG plus VGS, matlab DC plus AC. You guys can see here, when we increase the value of VGS, when we increase the value of VGS, we will get ID in positive. And when we are giving here VGS, we will give here less. That time current will goes downward. Current का value क्या हो रहा है? उसके साथ ही कम हो रहा है. And what will happen for the voltage variation? It will happen, but it is in opposite direction. मतलब when we are increasing VGS, we are getting negative. मतलब जो value है कम होते जा रहा है VDS का. And when we are giving low value of VGS, we will get higher value of output voltage. These are the variations of input and output signal. Now we will see about the AC analysis. In AC analysis, what will happen? We have to get AC equivalent circuit by shorting the DC battery and capacitor. ये जो यहाँ पे मैंने DC बैटरी और कैपेसिटर जो लिए थे, ये जो कैपेसिटर है और ये बैटरी जो है, if I am not giving, what will happen? We will get here AC circuit. ये यहाँ पे we are getting here AC circuit. So this is the circuit diagram. AC equivalent circuit for a MOSFET. If anyone is facing any issue, you can ask me. I have to take your attendance. So this is the equivalent circuit for the AC analysis. When we are shorting DC battery and capacitors, then we will get the AC equivalent circuit for the common source MOSFET. Here you guys can see the output, how we are getting here. Now we will see about the MOSFET as an amplifier. We have seen MOSFET is used as switch as well as an amplifier. Why? Because when we will get the value of ID current in a saturation region, we guys have seen the diagram of output characteristics. There we are getting the constant value of ID current. That's why we can use MOSFET as an amplifier. हम जब MOSFET जो है सैचुरेशन रीजन में होगा तो हम MOSFET को CS एम्पलीफायर बोल के यूज कर सकते हैं, बिकॉज वी कैन कंट्रोल और वी कैन एम्पलीफाई द वैल्यू ऑफ voltage here. So to operate MOSFET as a CS amplifier, you can see this is the circuit diagram here. We select the saturation region here because in saturation region we are getting the constant value of ID current as well as we are getting here quotient point Q point, which is in middle region. The voltage signal to be amplified and then superimpose DC input voltage will becomes equal to the VGS. मतलब VI का वैल्यू और VGS का वैल्यू क्या हो जाएगा? सेम हो जाएगा. एंड व्हाट विल हैपन? एम्पलीट्यूड ऑफ VI, ये जो एम्पलीट्यूड ऑफ VI है, should be very small so that operation is in saturation region and output will not get distorted. When MOSFET will be in saturation region, at that time we are getting their quotient point. ये जो हमने quotient point देखा है, we are getting, and as we are getting here quotient point at the middle of this DC line, we can use this as an amplifier because we are getting here constant value of ID current. This is the इक्विवेलेंट सर्किट फॉर द सिग्नल मॉडल ऑफ मॉसफेट. ये सेम सर्किट है बट वी आर सीइंग दिस सर्किट डायग्राम फॉर द सिग्नल मॉडल ऑफ मॉसफेट. Here you can see here we are giving here VGS and this is the current which will go through gate. The ID current will go through drain and you guys can see this is the Z. This is called as a transconductance. Transconductance. Since we, first of all, when we are not giving any VGS equal to 0 volt. At that time, what we'll get? We will get value of IG equal to 0. मैं यहाँ पे voltage ही नहीं दे रही हूँ, तो मुझे IG का value क्या मिलेगा? 0 मिलेगा. That's why when we are getting here IG equal to 0. And transconductance, how it is related with it is related with Vg. As we know, according to Ohm's law, V equal to IR. But Z, transconductance, is the reciprocal of resistance. So as we are getting here 0 current, we will get here infinite transconductance at the gate terminal. Means when we are giving VGS equal to 0 volt, we will get here infinite transconductance. Since IGS is 0, output of MOSFET is controlled by इनपुट वोल्टेज. ये IG का यदि वैल्यू 0 है तो आउटपुट वोल्टेज है वो कैसे कंट्रोल होगा? इट विल बी कंट्रोल्ड बाय इनपुट वोल्टेज. एंड दिस इज अ ट्रांसकंडक्टेंस. Then we see about the value of load output resistance, or we can say it is the load resistance. Ideally, after VDS saturation, what will happen? We are getting constant value of current, and if VDS will goes beyond VDS saturation, current will start to increase. मतलब saturation region के बाद क्या हो रहा है? current जो है फिर से increase हो रहा है, and as ID will increase. But in the practice, if you see practically, just because of the channel length modulations in VDS, ID will increase after VDS saturation, and we will get here output resistance. This is the inverse slope of output characteristics. This is the signal model of a MOSFET. These three, input impedance, transconductance, and output resistance, these are useful in a signal model of MOSFET. We can derive the values of input impedance, transconductance, and the output resistance in the signal model. When we are not giving any input, if we are giving VGS equal to 0 volt, IG will become 0, and we are getting here infinite resistance. And when we are giving IGS equal to 0, then it is transconductance is the ratio of output to the input parameter. So we will get transconductance, it will be the ratio of ID with respect to VDS. मतलब ये जो रेशियो है वो क्या होगा? ऑपोजिट टू रेडियस, ऑपोजिट टू रेजिस्टेंस. रेजिस्टेंस मतलब क्या होता है? वी कैन कॉल V इक्वल टू IR. तो R को हम क्या बोलते हैं? V by R. तो ये ट्रांसकंडक्टेंस क्या हो जाएगा? I by V. So we are getting here transconductance as GM equal to ID by VGS. And when we will apply here output, when we are giving VDS which will be greater than VDS saturation, what will happen? There is a channel length modulations, and we will get here increase in current. That's why its output resistance will be 0, or it will be a negligible. Thank you. If you guys are facing any issue, you can ask me. कोई difficulty है, किसी को कुछ समझ में नहीं आया है, तो तुम लोग पूछ सकते हो. Otherwise, we can conclude our class.